Hello everyone, this is Raman Rana here, your mathematics teacher, Cambridge International School, Dasua. Today we will move forward with the same exercise 13.3, question number 3, surface area and volume.
Hello my dear students, I hope you are enjoying at your home, and I do hope that today you will enjoy mathematics lesson also. We are doing exercise 13.3, question number 3. We are dealing with volume. As we know, the volume, if we are doing conversion of a solid liquid, generally the volume remains the same. Like if we are transferring a liquid like a milk from one container to another, the volume remains the same. So let's take question number 3. A 20 meter deep well with a diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform 22 meters by 14 meters. Find the height of the platform. So in this question, the earth which is taken out from the well, we are making a platform separately. If we have this a surface here and we have a well here, after digging the well, it is a right circular cylinder, and the depth of the it is given 20 meter, and the diameter is 7 meter. So radius is 3.5. So radius here is 3.5 meter. Now the earth taken out from here, we are making one platform. I will give you a very good example. Like in our school, we have a stage in a courtyard. That stage is a platform with having particular length, its width and height. Now in this platform, two dimensions, that is length and width, is given, and height we want to find. So I hope question is very clear. We are taking the earth, the mud from the well here after digging, and we are making one platform. So the volume of the cylinder, the well is cylindrical in shape, that is pi r square h, and the volume of this platform is in the shape of cuboid. The volume of cuboid is LBH, L into B into H. So here we will just make the comparison here, and we will find the height of the platform. So questions are very simple. As I have discussed in the previous chapter also, that calculation is very important, and it is a tricky calculation. If we are going in a right way, that is a very easy questions. So let's go for the calculation. So question number 3, solution here. We have the volume, that is pi r square h, and LBH. Let's take LBH left hand side, because we are interested to find this height of the platform. So the volume both side, that is same. So here L is equal to 22, width is 14. Here this is given 22 meter and width is 14 meter, and h we want to find. Let's take this H as a capital H here, because here small h already we have 20 meter, and the value of pi, unless or otherwise it is stated, we are always taking the value of pi 22 upon 7. So here we have 22 upon 7 multiply by r, that is 3.5 into 3.5, and h in this case is 20. So here we can go ahead, 7 ones are 7, 0.5, 0.5 into 22, that is 11 here, 0.5 into 22 is 11, and here 3.5 into 20, that is your 70. 20 into 3.5 is 70. So here we have 770, and the h, the value of h here is equal to 22 into 14 here. So here 11 ones are 11, 11 twos are 22 here, and again we have 2 ones are 2, it is 35, and we have now 7 ones are 7, twos are 14, and 7 fives are, so height of the this platform is 5 divided by 2, that is equal to 2.5 meter. So the height of this your platform is 2.5 meter. So that is the solution of this question. So question is very simple, maximum 2 or 3 marks. You need to understand that volume will not change, and here the volume of the cylinder is pi r square h, and the volume of the cuboid is L into B into H. Question number 4. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So this question is very important, examination point of view also. So you should know what is this embankment. Dear students, if this plane surfaces are filled, let's put this is a field here, and we want to dig one well here. So this circular shape, so if I am plotting here, this is a field here, and here I want to dig a circular shape well here. So there is 2-dimensional. So if this is the depth of the well inside, and this is always in circular shape, or in other word, here this is a circular shape well. Now this whole surface is the field, plane surface here. Now what we are doing, we are taking this earth from the well, and we are putting in this questions also the width of the, from this point we are taking a width of 4 meter outside. So we are first making a boundary here, and what we are doing, the width of this ring is 4 meter. Now whatever earth, the volume we are putting here on this surface only, whatever earth we have, or you can say mud, we will put it here. So we will get a kind of shape here, a kind of, if this is the surface, here we have the well, right? So we have outside the well this kind of shape, and inside we have this shape a kind of, you can say, threshold, or you can say on the plane, that for the protection of the well, so that any animals cannot enter in. So this solid portion, which is entirely equal to the volume of this well, it is empty from here. This one is the same well, the portion here, this one same well I'm talking about, and this new shape outside the well and above the surface, this is known as your embankment. So I hope, dear student, what is the embankment? When we take the mud from, or you can say earth from the well, when we digging the well, the earth taken out and it is spread in this, here the embankment is circular in shape. So this solid shape which is formed above the surface is called embankment. So first of all, you should know what is this embankment, and to solve, we know that the volume remains the same, whatever volume that is here, pi r square h for this well, and this volume is equal to the new shape we are framing here, or which is formed here, that is known as the embankment. So here it is also very important to find the, how to find the volume of the embankment. So volume of the embankment, here we have two radius, one is the r1, that is the small r1, and here that is r2. We know the radius r2 is r1 plus 4 here, because the width of that ring is 4 meter. So here volume, we can go for the volume of the bigger cylinder minus the smaller cylinder, because here this portion is empty here. So I hope you understood the question. So let's start the question here, solution. So in this question here, we have diameter of the well, that is given 3 meter. So what is the radius? Radius of the well is half of the diameter, that is 1.5 meter. Now height is also given. The height is given, that is 14. So the depth is 14 meter. Now the 4 meter wide ring on the surface here. Now we want to throw the mud here on this circular ring, and we want to frame the embankment. And in this embankment, we again want to find its height h here. So the volume of the two surfaces, that is you can solids, that is pi r square h, although all these, they are cylindrical in shape. So let's take here as a capital H for the embankment. So we have in this question pi, that is pi r square h is equal to, if this radius is r1 is 1.5, so r2 is, we will add r1 plus 4. So here it is 5.5 meter. So here r1 is 1.5, and in case of here your volume of embankment, that is pi r2 square h, that is capital H, minus pi r1 square h, because for both these, smaller and the bigger, because inside inside this embankment, the whole surface is empty here. So substituting the value, or if here we can take pi common. For this case, even h also we can take common, pi h, and r square, it is 5.5 whole square minus r is 1.5 whole square. So pi get cancelled with pi. In this case, r square is 1.5 whole square. H, in this case, we have 14 meter is equal to capital H into 55 into 55. So 5 5s are 25, 25 plus 2 27, so 275. So here 5 12 0 3. So we have 30.25 minus 225. 15s are 225. So decimals, it is 2.25. And here also we have, or we can change the sides. H is equal to 15 into 15 is, or we can write on 1.5 into 1.5 into 14 here, and subtracting here 25 minus here 2.25. So here we have 28. So this 28 will divide this side. Here is the point. So we have 14 ones are 14, 14 twos are 28, and we have now, this is 2.25. 15 to 15 is 225. So decimal will be here. So height of the embankment is equal to, that is 1.125 meter. So height, this embankment is 1.125 meter. So calculation is very simple. Question is very important. So I hope you understood the question, that the volume in both the cases, the volume of the earth which is dug from the well and the volume of the embankment is same. So volume of the embankment is volume of the bigger this ring, that is R2 is here 1.5 plus 4, that is 5.5. So the height of the embankment is 1.125 meter. Question number 5. A container shaped like a right circular cylinder having diameter 12 centimeter and the height 15 centimeter is full of ice cream. The ice cream is to be filled into a cone of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. Find the number of such cones which can be filled with the ice cream. So here we have one cylinder full of ice cream. So here the container right circular cylinder, diameter is 12, so its radius is half of 12 is 6 centimeter is the radius, and height here is 15 centimeter. Now from this container we want to fill the ice cream in a cone. A cone is also given with the radius, diameter is given 6, so its radius is 3 centimeter, and now at the top we have to put ice cream in the shape of hemisphere. Hemisphere. This is cone here. So the volume of from here cylinder we want to put the ice cream into the cones, and the question is find the number of such cones which can be filled with the ice cream. So here we know the volume of a cylinder is pi r square h. Same volume is to be converted here. The volume of a sphere is 4 by 3 pi r cube. So half of it is 2 by 3, half of it is, that is 2 by 3 pi r cube. R is same for the hemisphere also and for the cone also, and the volume of a cone is 1 by 3 pi r square h. So height of the cone is given. So height of the cone here is 12 centimeter. So this height h is 12 centimeter. So this is all about the question. So here we will compare the both volumes. If let the n is the number of such cone requires. So the volume here pi r square h, that is pi r square h is equal to n times this volume. This volume is the volume of hemisphere plus volume of the cone. Volume of a hemisphere is 2 by 3 pi r cube. For this side, right hand side, r is same 3 plus 1 by 3 pi r square h. So here we'll take pi common, and pi is outside. So here if I am substituting the value of 3 here, r is 3 here also, and r is 3. For both hemisphere and the cone, the radius is 3. So with 1 it get cancelled. Here 2 is left, and here only 1 is left. Pi is already outside. So I have 2 into 3 square is 9, plus here 1 is 3 is left, and h is 12 here. So 3 into 12 is 36. So we have pi, in this case r is 6, so that is 6 into 6, that is 36, and h is 15 here. So very simple calculation here. We will cut pi with pi, both cancelled, and the value n, I am interchanging the side. So n here is equal to 6 into 6, that is 36, or we can keep it simple here. So 18 plus 36, 18 plus 36 is 54. So here 54. So we have 6 ones are 6, 6 nines are 54, 3 fives are 15, and 3 threes are 9. So here we have the n is equal to 2 into 5. So number of such ice creams or cones which we can fill with this bigger your cylindrical box of the ice cream is 6 such cones can be filled. So I hope question is very clear to you people. Question number 6. The statement is, how many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 5 centimeter. So here we know coins are circular in shape, and if we have n number of coins, so the here if second coin, third coin, fourth, fifth, so on, we don't know how the number of coins, but when we melt these coins, we are framing one cuboid whose dimensions are given. So here we have two shapes. One is a cylinder shape. Number of coins we don't know. We are just assuming that let n is the number of coins. Let n is the number of coins, and here its dimension is given, length, width, and the height is given. That is 5.5, 10 centimeter, and 3.5 centimeter. Now these coins, the one very interesting thing that here diameter is 1.75 centimeter and the thickness is 2 mm. So we need to change 2 mm into your centimeter. So mm is millimeter. 1 millimeter, the relation with millimeter and centimeter. 1 meter is equal to centi. Centi means 100, milli means 100. Centi means 1/100th part of the meter, and 1 is 1000. So I hope you are very clear. We have discussed in the smaller classes these units. So 10 centimeter is equal to 1000 mm. So here we have 1 centimeter is equal to 10 mm, or we can say that 1 mm is equal to 1 1/10th of the centimeter. So 2m is equal to 2 mm is equal to how many centimeter? We will multiply with 1/10th. So here we have 0.2 centimeter. So we have to change. So this is the important here, that we have to change this thickness. That is in this case, this thickness is its h here. So in centimeter, 2 mm is 0.2 centimeter. Now come to the solution part. We have n times the number of the coins is equal to L into B into H. So here that is 10 into 55, that is 55 into 3.5 here, whereas pi, number of coins, pi is 22/7. R is now 1.75/2 into 1.75 into 2. Radius is half of the diameter, and h is equal to 0.2 centimeter. So here we will go for the calculation work. Here if we remove the decimals, then here 2 with 2, this is 11 here, and 7 2s are 14, 3, 5 here. So what I have done, I have removed the decimals all, that is 0 0 0 0 0, all 5 decimal points. I have here left with 11 into 25 into 175 is equal to 55 into 3.5. So here cross multiply, this implies that the number of the such coins is equal to 5 into 3.5 into 0 0 0, 0 and 0. So one decimal we can get cancelled with 1 0. This decimal with 1 0, and here we have 11 into 25 into 175. So we will go for the calculation. 11 ones are 11, 5, 5 ones are 5, this is again 25, 5 ones are 5, 5 sevens are 35, and 7 ones are 7, 7 twos are 14, 3, 25. So again we have 10,000 upon 25. So 25 fours are 100. So number of such coins, the required number of coin is 400. So dear students, I hope the question is very clear. Here we have converted this mm into the centimeters, and then we have n number of coins. The volume of n number of coins is equal to L into B into H. So dear students, we have left with 3 more questions. Question number 7, 8 and 9. You can go through these 3 questions. Tomorrow lesson I will take these 3 questions. They are also very important questions. With that, we will take the last topic, that is frustum of a cone. So thank you very much. Stay safe, stay healthy.